So temperature is a very common thing to measure, and it's often used to measure the performance of things. Most things have a performance that is best at a particular temperature, and that includes things like human beings and animals and stuff. So we'll often measure the temperature of living creatures to see how well they are performing. We also do this for things like aircraft and spacecraft and all manner of other objects as well. But yeah, measurement of temperature is a very, very common measurement. So most commonly in technical fields, we're going to use three different temperature scales. These are the Celsius scale, which we tend to use for measuring the temperature of everyday objects, the Kelvin scale, which we tend to use for measuring the temperature of cold stuff. So I don't know if anyone's planning on doing medical imaging for their career, but MRI machines operate at about 4 Kelvin. They are cooled with liquid helium. So the MRI technicians love to work in Kelvin. And then Fahrenheit is very commonly used amongst the general public. So while technical people will tend to always work in Celsius or Kelvin, they'll often do a conversion when communicating with the general public into Fahrenheit to communicate that information. So how are these three temperature scales related? Well, there are formulas that do this. So this is a little bit different because all of our other unit conversions, the units were related via only fractions, conversion factors. So what you see in these formulas are numbers that are added or subtracted. So why is that occurring? Well, that's occurring because these different scales have different 0 points. And so that's a little different because we know, like if we're looking at mass, 0 pounds is the same as 0 kilograms, is the same as 0 grams. If we look at length, 0 centimeters is the same as 0 miles, is the same as whatever length you want to think of, that's the same as 0 meters. But for temperature, the zeros are offset. So we have to account for that by adding or subtracting numbers to take that into account. So 0 degrees Celsius, as you probably know, is 32 degrees Fahrenheit, is 273.15 Kelvin. So they don't have the same 0 point, and we have to account for it. So we can have a look at this a little bit closer. So the Fahrenheit scale is offset from the Celsius scale by 32 degrees. 0 degrees Celsius is the same as 32 degrees Fahrenheit. So at 0 degrees Celsius, water freezes, and at 100 degrees Celsius, water boils. On the Fahrenheit scale, water boils at 212 degrees, and as I mentioned previously, it freezes at 32 degrees. So what this means is that in the space of 100 Celsius units, you've got a total of 180 Fahrenheit units. So you get 100 degrees Celsius for every 180 degrees Fahrenheit. So that's equivalent to saying that you get 5 degrees Celsius for every 9 degrees Fahrenheit. So that has to be accounted for as well, and that's why we've got this multiplier in here. So the 32 is to account for the offset of the 0, and then the 5/9 or the 9/5 is to account for the fact that the Celsius unit and the Fahrenheit unit are of a different size. So to convert from Celsius to Fahrenheit, you just got to use the formula. So degrees Fahrenheit is equal to 9/5 times the temperature in degrees Celsius plus 32. And so 9/5 times 37 plus 32 is 99 degrees Fahrenheit. So I always remember that 37 degrees Celsius is approximately 100 degrees Fahrenheit. You can use that to check whether you've memorized the formula correctly, right? So you always want to make sure that that works out. Now you shouldn't be memorizing formulas in this class, but later on you might need to have that memorized. Now, the size of a Kelvin unit is exactly the same as a Celsius degree. The only thing we have to account for is that the scale is offset by 273.15. So 0 Kelvin is minus 273.15 Celsius. but what you see is that the sizes of the units are the same. Now this is cool because if you're looking at a change in temperature, you don't have to do any conversion. If an object increases its temperature by 5 degrees Celsius, it also increases its temperature by 5 Kelvin. So that's cool. You know, the change on the Kelvin scale, however big that is exactly the same as the change on the Celsius scale. So that's cool, makes it a little easier. So a very common conversion that we'll do is to go from Celsius to Kelvin. And to do this, all you need to do is make sure you apply the correct formula. So Kelvin is equal to degrees Celsius plus 273. So that's what we're going to use. So we just take our Celsius measurement, add 273 to it, and we get our Kelvin measurement. You can see here I'm modeling putting a box around your answer. That's really helpful when someone's trying to grade your work. Okay, so let's have a look at some conversions type problems from Alex here. And we've got here compound SI units. And if you remember those ones, they're things that have more than one unit in a single measurement. Now, in this case, we're asked to do the complete conversion, not just state what conversion factors that we would use. So we have to turn kilograms into grams. There we go. And then we also have to turn deciliters into liters. So we know how to do this because 1 kilogram is the same as 10 to the 3 grams, and 1 deciliter is the same as 10 to the minus 1 liters. So how this is going to work is like this: 0.00896 kilograms, moles, deciliters. And my first conversion that I'm going to do is kilograms into grams. So I'm going to multiply by the conversion factor that has kilograms on the bottom and grams on the top, and I know that there are 10 to the 3 grams for every 1 kilogram. So that will get that bit done. And now I need to get rid of my deciliters, so it has to go on the top because it's on the bottom in my original units, and turn it into liters. And I know that for every 1 deciliter, there are 10 to the minus 1 liters. And now my deciliters will cancel, leaving me with liters. So then it will be grams, moles is unchanged, and then liters remains. So liters, grams, moles. You always want to double check that. And in this case, we're asked to evaluate it, so we'll have to actually put it into our calculator. So we want 0.00896. There it is. Turn the calculator on. 0.00896 times 10 to the 3. So I'm going to just do times 1 by 10 to the 3. And then times, we've got this fraction here, 1 on, and again I'm just going to do 1 times 10 to the minus 1. There we go. And enter. And it is 89.6. Now we want to get our sig figs right. This needs to be 3 sig figs because we started with 3 sig figs. So it's just going to be 89.6. Okay. So how are we going to convert from Celsius to Kelvin? Remember what we've got to do. Kelvin is just equal to degrees Celsius plus 273.15. So in each case, we just got to add 273.15. So 100 plus 273.15. It says round your answer to the nearest degree. So that would just be 373, right? Minus 196 plus 273.15. So that would be 77. and then so on and so forth. All right, so we may as well do the last one. Minus 36 plus 273.15. So that would be like 237. And again, we'd have to make sure that we're to the nearest degree. Now I just did those in, or not 337, 237. I just did those in my head. That's really bad practice. You should use a calculator. Okay, so that concludes this section on measurement of temperature. I hope you found it helpful, and good luck with everything.